Today we're going to learn how to measure capacitance using Multisim. We already know how to combine capacitors. That capacitors C1, 2, and 3 would actually combine like resistors in parallel. And capacitors 4, 5, and 6 in this circuit would combine like resistors in series. We're going to use the capacitive reactance equation shown here and simply rewrite the expression and solve for capacitance. We also know, based on Ohm's law, that resistance is equal to voltage divided by current, and if we plug in X sub C into this relationship, we can solve for X sub C, determine X sub C by looking at the voltage and the current in the circuit. So let's use Multisim. So we'll come up here and we'll pick analysis single frequency AC. In our case, we need to pick a frequency, and even in the voltage sources here, we've picked 1 kilohertz. So let's go ahead and just pick 1 kilohertz. We want 1 kilohertz because to solve for C, we need to pick an F. Our output voltage, or our output expression, we're going to use a relationship that I've already got printed up here, which basically says the same thing as the equation, this equation, but plugging in voltage and current for X sub C, putting in the frequency of 1000, and then multiplying it by the 2 pi. So we'll take this expression, come up here and simply add the expression, and seeing as how we have two different circuits, we'll do that for both circuits. The only difference between the two is the different voltage and the different current that we measure. And I believe we have everything ready now, so let's go ahead and simulate. As you can see, the output relationships here, the output is the actual measure of capacitance. Capacitance is the real part of this expression, and it says the value of capacitance for this circuit is about 6 microfarads, and the value of this circuit is 79 microfarads, and that agrees with our calculations.